Welcome to the Palace of Parliament in Bucharest, Romania. Today we are going to use this building to together do a problem involving scale and percent error. Jim is trying to make a model of the palace with a scale of 1 to 125. He wants to know how big the basic shape should be on his model. He knows the dimensions of the real palace are 270 meters by 240 meters with a height of 86 meters, errors as provided in brackets. To start the actual work, we need to make an orthographic drawing. As we saw in the at the McGill University School of Architect, this involves representing a 3D object in 1D on paper. To start with, we need to know the basic shape of the Palace of Parliament. It has been outlined in green with dimensions added here on this image. On the top here, we have an orthographic image of the image on the right. It shows the front view, the top view, and the right view. On the bottom here, we have the Palace of Parliament with the outline that we need to find the dimensions for the model. We draw the orthographic view. Using a scale of 1 to 125. We have discussed this a little bit earlier, but we'll continue this discussion here. 1 to 125 means that for every 1 unit on the model, the smaller object, there are 125 units on the original structure, the larger object. This can be shown by a conversion wheel. We can make a conversion wheel like this for any scale. First one, we have the smaller object on the right, the larger object on the left, and the scale in between. To get from 1 to 125, we multiply by 125. To get from 125 to 1, we divide by 125. Now to get down to the actual work. We have our orthographic drawing, so we know that we actually only have to figure out 3 dimensions of the model, as these sides are the same sides on the opposite side of the building. So, for side A, we know that the original size was 240 meters. Thus, we take this measurement, divide it by 125 meters. This equals 1.92. Same thing with side B, 270 meters. Divided by 125 equals 2.16. C equals 86 divided by 125 equals 0.69. Good way to organize this material is in a chart with the original size and the model size. Don't forget to put your measurements in. 1.92 meters, 2.16 meters. This is especially important if you want to convert to a different unit for clarity, as in you could put 0.69 meters or you could put 69 centimeters. But we still need to deal with the error. In grade 10, we learned that there are 2 different ways of displaying error, as in percent error or tolerance. For those of you who like to work with tolerance, we can easily convert from percent error to tolerance. We go 240 meters times 0.4%, or the 240 times 0.004, which equals 0.96 meters. That means with the original measurement of 240 meters, there could be plus or minus 0.96 meters error. So then the measurement could be given as 240 plus or minus 0.96 meters. 0.96 then divided by 125 equals 0.00768, which can be rounded up to 0.01, or plus or minus 1 centimeter error in the measurement on the model. Or since we know the percentage, we could take the measurement of the model, which we've already calculated to be 1.92, and times it by the 0.4% or 0.004, which also equals 0.00768 or 1 centimeter. We do this for all the measurements. 2.16 times 0.006 or 0.6% gives us 0.01296, or again approximately about a centimeter. Same with 0.69 meters times 0.012 equals 0.00828, or 1 centimeter. We can add these measurements to our scale, plus or minus 0.0 meters or plus or minus 1 centimeter, depending on the units we wish to display. Now we can add our dimensions to our orthographic drawing. A would be 1.92 meters, which is shown on both the right and the top figures. On the front we can show 2.16 meters for B and 0.69 meters for the height. Then all we need to do is add the disclaimer that all dimensions are accurate to 1 centimeter. Then we can hand this diagram off to Jim and he can create his model as he would like.